Okay, welcome back. So this is chemistry question 43 from IMAT 2019 past paper. So I'll be answering this question. So it says consider the following reversible reaction at temperature T. So we are given with this reaction. So there's no identified molecule like let's say carbon dioxide or anything. It's just some alphabet. Okay, A plus 2B giving 2C plus D, but this is reversible reaction. Okay, not complete reaction. So at equilibrium, there are zero point 0.5 moles of A, zero point 0.2 moles of B, zero point 0.5 moles of C, and zero point 0.8 moles of D, all in a vessel of volume V. Okay, so now we have to consider the most important thing that, for instance, uh, we have this container, okay, and this is a solution. So we have all these A, B, C, and D, which represents the chemical species that are reacting and forming the reversible reaction. Okay, so we have this A, we have B, C, D, all dissolved in this solution, and the volume of this solution is V. Okay, so now we are given with the moles of each of these species. Okay, A, B, C, D, which reacts and forming this reversible reaction. Now, what is the value of equilibrium constant Kc at this temperature? Okay, so one most important thing you must know is that Kc means equilibrium constant. Okay, so equilibrium constant for concentration. Okay, so Kc here is equilibrium. I'll just write in short form. Equilibrium constant for concentration. Okay, it's for concentration, and for this question, since we are given with moles and volumes, so most probably the type of concentration we are going to use is molarity, which is a molar concentration given in capital M, which is basically moles of a solute by volume. Okay, so as we know, this equilibrium constant Kc that we're supposed to find out for this question. And we must know the formula, the expression for Kc. Okay, so now we're given with this chemical equation. Okay, so we must know this is a reactant. Okay, we will consider this as a reactant, and this we will consider this as a product. Okay, so this reactant and a product. Okay, so now the formula for Kc is Kc equal to, so the fraction form. So first of all, I'm going to go with very general expression. Okay, so the most general expression is the product. Okay, the concentration of product. So this is the one thing we must specify, the concentration, because we're using Kc, the equilibrium constant for concentration. And also this one, reactant, which we'll have in the denominator, reactants. Okay. Okay, so products divided by the reactant. Okay, so that's the formula. And the most important thing is the power. Okay, so the coefficients. So this is a coefficient for the product and the coefficient here. Okay, now the most important thing you must know is that these coefficient here represents a power. Okay, so the product in this closed bracket. So this closed bracket over here represents the molar concentration of chemical a chemical substance in a solution. Okay, so molar concentration of chemical substance in a solution, so that's what it represents, the square brackets. And over here this coefficient, over here the numbers that we have on our left side. Okay, so this is a species, okay, a chemical substance, So whatever number we have on this side, this represents the coefficient. And this coefficient will be represented as a power, okay, in this Kc expression. So coefficient of that chemical substance in the reaction represents as a power, okay. So product to the power of something, okay. So we are given with these uh, coefficients over here. So here we are not given with anything, okay. So with the chemical species that are not given with any coefficient clearly, so we'll consider that as 1, okay, and also here as 1. Okay, so now we know we don't need to also balance the chemical equation since we're not asked, and since the chemical is not defined, so there's no need of balancing the chemical equation. So we just right away we consider this as balanced already. Okay, so this is the general expression. Now we have to uh, substitute this general expression with the given chemical species in this reaction, which is in form of A, B, C, D. Okay, so it will be like this. So in square brackets, we'll close all of them. So remember, we have the products. So the products are C and D. Okay, so the C to the power of 2. Why? Because we have the 2 as the coefficient of the C. Okay, so C to the power of 2 and multiply by B. Okay, so these two come in the products and we have the reactants A and B. Okay, so the denominator will be the reactants. So A, we know we have no coefficients, so we'll consider that as 1. Okay, but it has a coefficient, but it is considered as 1 because there's 1 mole of A reacting with 2 moles of B. Okay, so for B, since there's 2 moles reacting, so it will be to the power of 2 as a coefficient. Okay, so power of 2. Okay, so now this is the expression that we're going to use for this question. And now, since we know that we're going to use molarity because this Kc is for concentration, where concentration is moles of a solute divided by the volume. So these are solutes, okay, and the volume mentioned over here is V. Okay, so the volume is not specified, okay. So what we can do is that we can just write as V, okay. So we can write V in the expression. So we know that for A, the concentration is 0.5 moles by V, and for B, it is 0.2 moles by V, and for C, it is 0.5 by V, and for D, it is 0.8 by V. Okay, so for each of these species, the volume is going to be V because it's all considered as an additive volume because all of these chemical substance are dissolved in this solution, okay, and the volume of the solution is V, so that's why we're going to use V for all of these solutes that are dissolved in this solution. Okay, so now we're going to substitute for the value of Kc in this expression. So for C, in the place of C, as I've told you, it's 0.5 by V. Okay, so 0.5 by V, okay, squared times for D it is 0.8 by V. Okay, 0.8 by V squared, and for A it is 0.5 by V to the power of 1, and oh sorry, so 0.1 because there's no just 1 moles of D forms as a product. Okay, so 0.2 is for B, 0.2 by V squared. But now the most important thing we know is that we can cancel out this V altogether. So why is that? Because we know in the denominator it's going to be V cube because V square, we know V square times V1. So we know they're going to add together. Their powers are going to add together. So this gives us V cube. So this similar thing also happens in the denominator just as in numerator. So hence we can cancel the volume out. Okay. So as we cancel the volume out, we're just left with these things. Just we've simplified it. So 0.5 squared times 0.8, 0.5 times 0.2 squared. Okay, so our answer when we calculate will be 10. Okay, so it is 10. So, and also most important thing is that most of the equilibrium constant are unitless. And we know because both of them have moles per volume. So we know they're in cubic form and both of them are like terms. So that's why we cancel out altogether. So it's unitless. So Kc is equal to 10. So we know it's option C, which is 10. Okay, so that's how we solve this question. So thank you guys for watching my video. I hope you find this video helpful. Please leave a like and subscribe to my channel. Thank you guys. Bye.